In the previous video, we learned how to simplify sets, so this video will help you to solidify that concept with several other examples. Okay, the first example we want to consider is square root of 63. How do we simplify this? Now recall we said simplifying set means reducing it to its lowest form possible. And 63 is basically 9 times 7, right? Now if you look critically, you can see that 9 is a perfect square of 3. So 3 times 3 gives 9, which means we can rewrite this whole expression as this. We just separate them all under a square root. 9 becomes 3 squared under a square root, and then times 7 also under its square root. Now we know a square root of any number squared becomes the number itself, because we learned the square root is a power of half. So half times 2 becomes just 1. And so all of this becomes 3 to the power 1, which is basically 3. And so we have 3 times root 7, and then eventually 3 root 7. Now the second one is 120. Try this one as well. If you find it difficult, try using the prime factorization method, where you write 120 in its prime factors form. Look at the number you can express as a square, and then take those two numbers, multiply by the other three numbers. If you implement that, this is what you are going to get. You will get 4 times 30. Alright. Now 4 can be reduced or rewritten as 2 to the power 2 times 30. And so this is what we get. The 4 becomes 2 to the power 2, and then 30 becomes just root 30, because we can reduce root 30 to any simpler said form. Alright, we can reduce this to any simpler said form, so we maintain it. This goes to tell that the fact that a number is huge doesn't necessarily mean it can be reduced any further, and the fact that a number is small, or a said number is small, doesn't also mean it can be reduced any further. So 4 is relatively smaller than 30, but 4 can be reduced in this form. Alright, now that we have this, we know the 2 cancel the square roots, making it 2 times root 30, and eventually 2 roots 30. How about this? This also looks like a huge number, so an easier way is to try to implement the prime factorization. Look at the number that we can square in the prime factorization, multiply by the other numbers. This concept was learned in the previous video, so if you are finding it difficult, I recommend you look at the earlier video so that you can understand it, and a link to that video is in the description, so you can look at it. Alright, 850 is 25 times 34. 25 times 34 gives us 850. Now we can separate all of this. 25 can be expressed as 5 to the power 2. 5 times 5 gives us 25. And then 34 can't be reduced any further in a said form. Now we know square root of 5 square is 5. And so eventually we get 5 root 34. How about this? 18. Quite an easier one. 18 is 9 times 2. 9 can be expressed as 3 to the power 2. And then square root of 2. And so this becomes 3, this becomes root 2. And then eventually 3 times root 2, making us have 3 root 2. Finally, square root of 16, right? 16 is 4 times 4, or 4 squared. And then that means when this one cancels this, we have just 4, which goes to tell that the square root of 16 is not a set. It actually gives an integer. It's not a set, it gives a rational number. So like we earlier learned, the fact that a number is under a square root doesn't mean it is a set. When reduced, it can be a rational number or an integer, and that is when we can actually tell whether it's a set or it isn't. So this is it for the examples of simplification of sets. Next, we look at how to add and subtract sets. Look at that one in the next video, and make sure you like, you share, you comment any other thought you have on this subject. Okay, see you.